Okay, so which of the following statements concerning xenon tetrafluoride is true? So they already have the Lewis structure given, so let's write that down as well. We have xenon as our central atom, and then 4 single bonds to these fluorines, and then each fluorine has 6 non-bonding electrons. And then the remaining 4 electrons are on the xenon central atom in the form of a lone pair. So now let's see the options they give us. Which of these statements is true? Electron geometry is octahedral, molecular geometry square planar, the bond angle is either 90 degrees or 180 degrees, and this molecule is nonpolar. Okay, so let's start off by counting the number of charge clouds that are on the central atom, which is xenon. So by charge clouds, I mean the lone pairs and also all of the bonded atoms. So we can see that the xenon contains 2 lone pairs, and there are also 4 bonded atoms. So using a VSEPR chart, we can find out its molecular shape and electron geometry. So this should be on the next page. So when we have 4 bonded atoms and 2 lone pairs, we get a square planar molecular shape. And we also get an octahedral electron geometry. And the hybridization is sp3d2. And the bond angles for all of the bonds is 90 degrees. Okay, so we also need to find out whether or not this molecule is polar or nonpolar. So the steps in finding out whether or not a molecule is polar or nonpolar is to first find out if we have any polar bonds. So to find out if a bond is polar, we need to calculate the electronegativity difference between xenon and fluorine. So now let's look up the electronegativity values for both xenon and fluorine. Okay, so these show all the different electronegativity values of the elements. So fluorine has an electronegativity value of 4, and xenon has an electronegativity value of 2.6. I think these are a bit rounded, but if we were to subtract 4 minus 2.6, you get 1.4. So therefore, we can say that the bond is polar, and this is because our electronegativity difference is greater than 0.4, but it's less than 1.69. So let's draw out dipole moments towards the fluorine to show that they're more electronegative. But if we look at the structure of our molecule, you'll see that we have the 2 lone pairs, can kind of be drawn like that. So because of this symmetrical shape, the overall molecule is nonpolar. So I can say that xenon tetrafluoride is a nonpolar molecule. And the reason for that is because the dipole moments that are caused by the fluorine are cancelled out. So the dipole moments cancel each other out. And another way of saying this is that we have a 0 net dipole moment. And we can say this is because we have a symmetrical molecular shape. Okay, so now let's see what the junior tutor said. Oh, well, first we had to look at these different statements. So electron geometry is octahedral, so that's correct. Molecular geometry is square planar, which is correct. The bond angle is 90 degrees, so I guess that's correct, because I said either or. And then finally, it is nonpolar. So that is correct as well. So it's option A. Okay, so the junior tutor said that the properties of a certain molecule, such as electron and molecular geometry, bond angle, and polarity, can be determined from its steric number, or the number of atoms bonded plus the number of lone pairs attached to the central atom. For a molecule of xenon tetrafluoride based on the given electron dot structure, we have 4 atoms bonded plus 2 lone pairs attached to the central atom. Thus, it has a steric number of 6, which corresponds to the following: octahedral electron geometry, square planar molecular geometry, bond angle of 90 degrees. I would just say it's, yeah, I guess it could be 180 if we look at the bond angle between the 2 electron groups, the lone pairs. And the molecule is nonpolar because of its symmetry, which cancels out any dipole moment. So the correct answer is A. Yep. So the solution